Hi, I'm following along with Paul McWhorter's Raspberry Pi Pico W lessons, and um, I took a vacation last week, so I missed lesson 84, and now he's on 85, and we're talking about making binary counters with our newly uh, found skill of debouncing our interrupt buttons. So. Uh, the Paul in lesson 85, Paul showed the answer to one way of doing the uh, counting up with the um, binary using the modulo operator, and I thought it was an interesting way, and it worked out fine for him. But uh, I wouldn't have done it that way personally, but uh, it was a valid way to do what he wants to do. But then the homework for the lesson 85 was to make an up down counter. And I haven't even programmed this, but the logic, running through the logic on it, I think it's going to be a problem for him because if you're decrementing and let's say, okay, if you have up down, if you want to push a button to go up, if you start at 0 and you want to push a button to go up and you go to 1, then your logic on that's going to work fine and you're going to toggle the first LED. But then say you don't do anything else, but then you hit the decrement counter, the decrement button, and the counter goes back down to 0. I think right away you're going to have a problem because if you use the modulo operator on any value of 0, no matter whether it's 2, 4, 8, or whatever number, you're going to end up with a 0. So all of your methods are all of your ifs are going to be true and you're going to toggle all of your LEDs. So I'm pretty sure that Paul's probably going to have to do a different way or figure out a way around that idea. I'm not sure how he would figure that out, but just putting a when you get back down to 0, he's going to have a problem. Um, like I say, I have no clue what his idea is for it, but um, I do. I think it was an interesting way he did it, but overall, using a toggle when you don't, you have to have your thinking on right because you got to know that your last toggle was in the right place and everything, and it just seems like toggling rather than setting the LED to the right value is not really the way to go. So my idea was to set the LED to a proper value with that. And way back in lesson 3, Paul was introducing us to binary counters, and um, his students who have been around for a while came up with over a dozen ways of doing that, and myself included. Um, Paul had told us that in those beginning lessons that we could, I guess, help out people and maybe show alternate ways of doing things. He certainly didn't do it the easy way back in lesson 3 because students didn't know a whole lot, the beginning students. But so anyhow, there was a lot of answers, and I'll get to my favorite way, and I'm not going to discuss all the others. But if you go back to homework from people, um, including myself, you can find it. So also, yes, I did a video showing my way of doing the uh, way I did it in this same video back on my lesson 3 video that I did for the class. So I will link that in the description so you can get an idea. And that explains what's going on in the code. Um, I think I brought that up. Yes. This is, like I say, I do a good explanation. I even made a little Python program to show you how it was done and everything. So, like I said, I'll make sure I link to it in the description. if you missed my homework in there. It looks like it only got 67 views, so maybe a lot of people missed it. I don't know. So anyhow, let's get back to where we're going. So we're going to go to the program in uh, Thonny. So the first thing, um, in past 83, I guess it was, that I decided to, when we did the debouncing, I decided to um, put the debounce part in a library module that I have so that I can just set up a pin and it'll automatically return a debounced value. It won't return unless it's been debounced properly. So it won't go to the handler unless it's debounced properly. So like I said, that was like 25, 24, 25 lines of code to set up that module for doing that. So, but once you got those modules set up, to set up a object, it's just one line of code. And you can go back to my past video to talk about, debounce times and all that stuff in it. But so we need an up and a down pin. So it was just a matter of adding one line of code. I didn't have to code anything else on it. It automatically was going to do that for me. So that's one thing. What do we want to go to next? Okay, so um, I think Charlotte was the original one that did this in our class. I don't know whether I saw it anywhere else before Charlotte did it, but um, when you have multiple LEDs, it's easier to set them up in a list so that you can refer to them by their index number. That way you can iterate over the LEDs without having to use their names and everything. So, um, and you might notice I got lazy again. I had 3 LEDs already on my board. They're 3 different colors, and I didn't feel like wiring up a fourth one, so I used the onboard LED as my fourth one. So there, like I say, when you set them up like this, the way my program works is this is like the least significant. So this is our 1, this is our 2, and this is our 4, and this is our 8 LED. They go from least significant to most significant. So if you look at the code, these 2 lines of code are what uh, uh, loop through the 4 LEDs. And what you're doing is you're getting an index. So your index is going to be 0, 1, 2, and 3, or lead 1, 0, 1, 2, and 3. And we're doing the value, and we're setting the value of it based on bit shifting and bit math. And like I said, go to the video. It's an 18-minute video, so if you need to understand why that's doing it, I tried my best in 18 minutes of how to show how that works, the bit shifting and using the and everything. So you're able, once you have your LEDs set up in a list, it only takes 2 lines of code to go through and set them. So that was the easy way of setting them. You didn't have to, and you're not toggling or anything like that. You know by what number you have, you want to do it. So that's that part of it. So okay, so the next thing you notice is that both my up button and my down button are using the exact same callback, and we actually only have one callback thing in here. And you might wonder why that is. It's how it works with 2 callbacks. Well, if you remember, Paul is talking about, well, we got to put something up here because we're passing in a pin object from our IRQ, and he just kind of just bypasses it. I don't think he's probably going to cover this, but that pin object is actually the pin that you use down in your uh, when you created your IRQ object. Um, Now, like I say, I'm just passing this to my library, but I'm using that same pin. I'm just passing it through to the IRQ same way. So um, the thing about that is that when you pass this back in, you can also refer to it by the name of your object dot pin, because that's what it is. It's your pin here. So it's up button dot pin and down button dot pin, and that'll give you that's it'll give you tell you which of the objects you have up here. Um, so I'm actually using this pin to decide which way I want to go with my count. So you can see down here, passing in global again. So I know we don't like globals, but that's passing it in. So what I'm saying is doing two ifs here. If the pin that you're passed in is equal to up button dot pin, then you know that you're incrementing. And then we're using the modular 16 because we want to keep this number between 0 and 15 so that, it's going to do that. So um, that video explains the modulus operator as well for making like a round robin counter that resets automatically. In the same way as if the pin is equal to the down button pin, then we know we're taking one off of our count and doing it that way. And we're doing the modulus on that as well. And I probably could have used two different callback methods, and it probably would end up about the same length of code. I wouldn't have had to use the if statements up here. I would have known that I was adding one or subtracting one. And my extra code was only 2 lines. This code doesn't matter. It's going to run whether you increment it or whether you hit the down button. So either way, so like I say, I could have copied this code twice. It wouldn't have mattered, but I just wanted to show how you could use that pin object that we just think is a throwaway object, but it is useful in some cases. So that was kind of interesting. And let's see, one other thing is when we do our try and accept, we can turn all of our lead pins off in a loop as well. So we can just say for pin and lead pins, and we can say pin dot off, and it turns them all off on the way out with just 2 lines of code. So like I say, with a couple additions, you could have put 4 more pins in here and wire up 4 more pins and change this to an 8 and change this to a 255 or 256, I guess, 256. And the rest of your the rest of your code would be exactly the same. So, basically with 20 more or 40 more characters, you could, and changing a couple things in your program, you could make us an 8-bit counter just as easy as that. And anyhow, that's all I got, I guess, on this one. And like I said, I'll leave the description if you're curious about how this works and didn't watch my video before, you can check that out. Anyhow, that's all I got for today. Have a great day. Thanks, Paul, for all you do. And um, I really looking forward to the PIO in a couple weeks. Have a great day, everybody.